Hey, fourth grade, how are you? This is our only video for this week of May 4th through the 8th. You're going to need your same packet that we've been using, and today we're going to be on page 82, which is going to be a little tricky to find, but we're also going to be on page 83, okay? So starting off on page 82, and make sure you have a pencil. So if you don't have those items, let's go grab those real quick, okay? All right, so on page 82, this is a page that is in the back of your packet. Actually, at the top of this page, it's also going to say, whoops, let me hold that down there for a second. It's going to say extra on it. So if you look, you'll be going through the hundreds, and then the pages will get a little smaller. And anyway, you have a page 82 in your packet. So what I'd like for you to do is flip back to the back of your packet and find your page 82. And we're going to be working on, let me shove that back up now. We're going to be working, there's only two problems on this page. The reason it's called extra is I thought we might have to have a little bit of extra work on this, so I thought we would go ahead and do that today. Do the little bit of extra work on that. So what I'd like for you to do is look at number 1 once you found page 82. If you have to pause the video to get there, that's fine. Then just start it right back up. But we're going to be using our cube strategies like we always do. I'm not going to put that paper up again. You know how to do your cubes by now, okay? So we're going to read and then circle and box and do all the other stuff that we need to do. So here we go. 46 people entered a baking competition. Contestants could bake cakes, cookies, or brownies. The number of people who baked cookies was 3 times the number of people who baked brownies. The number of people who baked cakes was 5 more than the number of people who baked cookies. Which strip diagram correctly represents the information? And remember, if you've been with me for the last 2 weeks before this, these are the type of problems that we've been working. So I'm going to come up here, just do a little bit of circling and maybe some underlining, and then I'd like for you to solve this problem on your own. Don't do that before we've thought through it though. So it says 46 people. So we circle numbers and their units, and I'm just going to put the units underlined there. But I like to see my numbers as digits, so I'm going to put 46 above the people. Okay, so 46 people entered a baking competition. So that's the total. So I know that when I'm looking for my information down here, that I can't get any bigger than 46. Okay, it says that I have contestants that have cakes, cookies, or brownies. So I know I'm going to have 3 sections that I'm looking at. So I'm going to have to look at cakes and at cookies and at brownies. So I want to make sure that I have all 3 of those before I go on. And it says the number of people who baked cookies was 3 times the number of people who baked brownies. Whoops, let me give that a little bit of help there. I slipped. Who baked brownies. And then the number of people who baked cakes was 5 more than the number of people who baked cookies. Okay, so we have a lot of information to go through there. Pick through it. Once you've made your decision, come back and then see if you got it right. So right now, pause the video and then come back and check. All right, did you think through it? Now, if you notice, I haven't gotten my answer circled yet, but go ahead, take a look. This is how I thought through it. I thought through here, and I knew that times was a multiply. Whoops. And then I know more is going to be some adding here. And so when I read through, I know that cookies are 3 times as much as brownies. Okay, so I knew brownies were going to be B, okay, and I did times 3. And then if I read here, it said that cakes were 5 more than the cookies. Well, cookies are B times 3. So I knew that whatever the cookies were, the cakes have to look exactly like it, but have a plus 5 with it. So if I look here, which one's the littlest? I know that if I look up here, everything was being compared to brownies. And so I know that brownies is going to have to be the littlest because cookies are 3 times as much as brownies, and then cakes are even bigger than cookies. So I have to make sure that I do that first. So if I look here, brownies are way too big. Brownies are not supposed to be the biggest thing. I know that's not correct. Well, the very first thing I checked was that everything equals 46. So I had to check every single one of these. So if I look here, brownies are little. That's good. And then cookies need to have 3 times the size of brownies. But I have this plus 5 added on. On my cookies over here, I abbreviated that CO. I'm not supposed to have a plus 5. The cakes are supposed to have a plus 5. This was close, but not quite. So I go to C. Brownies are little. Good. Cookies are 3 times as much. That's really good. But then I come down here to cakes, and then this cakes is only the same size as brownies, and it doesn't even say what this little bitty box is. So we don't even know what that is. It didn't even tell us. So that can't be it. I mean, it didn't even have enough information. But if I drop way down here to the bottom, okay, I have a brownies. Then I have brownies that are done 3 times. That's a times 3 then. And then I have the exact same size here for the cakes, but I have a little extra 5 on the end. That's what I was looking for. And so hopefully by doing enough digging, you found that D was the answer. Okay? Let's try this one now, number 2. This one says, the strip diagram below represents the amount of money that 3 people have. All right? Now, we'll have to investigate this. Okay, so we have boxes that are the same size and then a little extra added on here. So we've used these enough where we can probably find our way through this. Then it says, which of the following correctly represents the information in the strip diagram? And if I notice my answers, they're using an X for this. So I'd like for you to notice that we're talking about 3 people. We want to see which information correctly represents this given to us up here. So pause the video, figure out which one of these is going to work, which one's the correct one, and then come right back and turn the video back on and see if you got it correct. Okay, so pause now. All right, did you make your choice? Well, when I come up here and I've investigated my answer choices, I notice that they want to use the unknown as the X. When I am trying to figure out a picture, what I'd like to do is narrow it down to the very smallest thing. And what I noticed was Carl was the very smallest thing. And all the other boxes are the same size except for this little 2 out here. So I made Carl the X. And then anything that was the exact same size as Carl's box, I put an X in because that's its name. So Carl is X. Rita is 3 of those X's. So I can say 3X. Or when I say 3X, that means 3 times X, or 3 X's. All right? Well, Ben is the exact same size as Rita, a 3X, but he has a little 2 tacked on to the end. So that means I added 2 to the end of that one. So let's come down here and let's look and see. Rita is not our smallest one. And we don't have anything that really represents a subtracting at all in this problem. So what I'm going to do is I'm going to say, no, that is not it. Okay? And yeah, it kind of looks like Carl is 2 less than Rita, but that's not how we would represent the way this looks, okay? We've already decided Rita is not X, and Ben isn't just a +2 more than Rita. So that can't be it. And we've already decided this really isn't showing a subtracting at all. So let's look at this. Carl is our X, just like us up here. Okay, so we have Carl as our X. Rita has 3 of the same size things, or 3 X's. Ben has 3 X-size boxes and a +2. I think this one's going to be ours right here, but let's look and see this one, because this one also has Carl as the X. And then it has Rita +2. Well, what they wanted you to look at was saying, oh, but there's 2 more boxes here. That's a +2. Now, we can't just say that's a +2. If we do a +2, we have to make a new box over here because we really don't know how big Carl is, okay? And a +2 would have to be shown with just a little 2 sticking out there to the side, okay? So that wouldn't work. And then Ben couldn't be a +3, an X +3, because, first of all, he has 2 tacked onto the back of his. His would be a +2, not a +3 of anything. So that is not going to be our answer. So hopefully, with all our practice over the last few weeks, you figured out that that's the answer. Okay? All right, we're going to go on to the next page, and that's page 83, which you're going to have to flip back to the front part of your book for that, and that's where you'll find page 83. Now, I'm not going to go over these as extensively because these are a little bit easier. These are just basically what I call, this is a function table. And so what we're trying to find out is just how this table works, okay? And a lot of these you can just think as an input-output, just like this picture shows. What happened here to make me get over to here is what we have to decide to do. So, hopefully you're now on page 83. Okay. And we're going to look at number 1 using our cube strategy as usual. It says, what number is missing from the output column in the table below? We will not be able to figure that out until we can find one rule that makes this table work. So we have to find the one thing that can get us from here to here and here to here. Okay? And I'm going to help you solve this one just right away. I'm going to need a skinnier pen for that. Here we go. All right, so if we look, I need to figure out this, so I'm going to come here. What would it take to get from 20 to 5? Well, were we getting bigger or smaller? Well, we're getting smaller. The 2 operations that make things smaller are subtract, that's a terrible subtract, and a divide. Okay, so if I were to use subtract, that would be minus 15. So 20 minus 15 would be 5. Now, is 28 minus 15 7? Well, if I come over here and I say 28 minus 15, well, I can look right away and see that 8 minus 5 is 3. Well, that's not going to give us a 7 like we want. Okay, it's going to give us a 13. Well, that won't work. So what we're going to do is, well, subtracting isn't going to be what makes this table work. So let's come back and we're going to have to grab the divide. All right, so what would you divide 20 by to equal a 5? So we're going to be just finding a missing number here. 20 divided by what? Or 5 times what is 20, if it's easier to look at it that way? 4. That one was pretty easy, wasn't it? Well, if I divide by 4 here, would this work? Or let's work backward. 7 times 4 equals 28. That's true. Okay. What if I divide 40 by 4? 40 divided by 4 equals, well, of course, it equals 10. So we know what we're working with. Okay, the rule for this table is going to be a dividing by 4. So if I take that same rule place it in here to help me find my answer. What is 16 divided by 4? 4. And so I know the number I'm looking for in the output, okay, in the output column. So what number is missing? It's going to be 4. Okay, so do you see how those work? Right. I'd like for you to go through, and I want you to do number 2 and number 3. So I want you to solve number 2 and number 3, see which answers you get, and then you can come right back and then we'll talk about and check these answers. So right now, pause the video and do number 2 and number 3. Then come right back. Okay, did you make your choices? Let's look and see. I didn't remind you to use your cube strategy, but that's something that you should already know to do, okay? So what I did was Jeremy made a table to help him convert yards to feet. He knows that 1 yard equals 3 feet. Well, I gave myself a little picture out here too. If I had a yard, it's 3 feet. If I have 2 of them, it's 2 threes. If I have 3 of them, it's 3 threes. What I'm noticing is that each time I do that or I make this picture, I'm multiplying by 3. So, looky here. I filled in the part of the chart that wasn't filled in. And so when I did that, okay, and I could have drawn a picture for 4 things and 5 things and seen how much that was if I needed to have a picture, but I stopped at 3, okay, or at my little 3 yards. So which numbers can Jeremy use correctly to correctly complete the chart? Well, if I look, there's only one thing that matches exactly, and we needed the 6, 9, 12, 15. Okay, that one wasn't too terribly hard, but what's important to know is that you worked the problem out, that you showed your work and what you were doing. Let's go over here to look at number 3, and it's going to be the last thing that we do today, so hopefully you've had a little bit of fun working on math today. And let's look at this, read it together. A restaurant owner used the rule times 15 to make a table showing the number of sandwiches he can make with different amounts of bread. Which table could he have created? Well, if we look, if they're telling us what is going to be the rule for the table, times 15, and times, of course, we know, is multiplying. Let's see which one goes with our times 15 rule. And it gave it to us on this one, so it doesn't get much easier than that. Now we just have to pick through these answers. So I'm going to pull these up so we can look at them. If I look at A, 1 times 15 is 15. I put a check mark there. Yay, that one matches. 2 times 15 is 16. No. And actually, if you look at this, okay, there's not any rule that would really fit this chart very well, but it's definitely not times 15. So, nope, that can't be it. Let's try to make this one work. Okay, 1 times 15 is 15. Good. 2 loaves of bread, 15 sandwiches. Well, times 15, that's 30. Okay, can make 30 sandwiches. 3 times 15 is 45. 4 times 15 equals 60. This is looking like this is the one that we probably need to have as our answer. But let's check the others. And if I went too quickly through this, you know, I just know what the times 15s are. But if you didn't know the times 15s, you would have just needed to drop over here and then just set yourself up a simple little 2-digit times 1-digit problem, and you could have solved that just as easily. Let's look at C. 1 times 15 is 15. Check. 2 times 15, it's not 45. This isn't going to work. If it doesn't work even in one spot, it can't be your answer. Well, let's go down here to the very bottom one. 1 times 15 is 15. Check. 2 times 15 is not 17. So that one didn't work. Now, if I had looked here, if this This could have maybe fitted another problem, but not the problem that we're looking at. Okay, so our hard work paid off. But did you notice that I continued on? Even though I was pretty sure this one was the right one, I needed to make sure I wasn't thinking wrong. So, hope you learned a little bit today. This is, like I said, our only video for May 4th through the 8th. Sure do miss you guys. I hope that y'all are having fun while you're at home, but being safe. But until our next video, bye-bye for now.